All right, let's come up with the formulas for each piece graphed here. And we also have to come up with the intervals of x that fit each piece. So maybe that's the easiest part to start with. And we can just kind of highlight the grid lines that go through the x-axis at the beginning of each part, each piece, and the end of each piece. Okay, so there's that. In fact, we don't even have to really highlight it that much. We just kind of have to draw down from the leftmost piece, point and then find the x value there and the rightmost point. So that first piece, we're going to be doing x between and equal. You can start with -6, so it can be equal to -6 or greater. And then on the right-hand side, I think that's closed. Yeah, it's closed. So we'll again use the less than or equal so that we can include -3 in this piece. Right? Now the next piece over, get my yellow back. So now this piece has an open circle at x equals -3 and a closed dot at x equals 1. So we'll do x between, starting at -6 but not equal, and ending at 1, and yes, it can be equal. Okay. Finally, our last piece picks up at x equals 1, and then x is going to be greater or equal to that because it's a closed, oh sorry, it's an open dot, so I should have just made it, and let me change my color. I like to do colors here. Let's see, let's do green. So starting at 1 and strictly greater, not including 1, because it's an open circle here. And then the farthest x value to the right is here, okay? Because you can see that aligns with that rightmost point of that final piece. So less than or equal, because it is a closed dot right there, to 6. Okay, so that was probably the easy part, right? At least it's not very much work. Okay. Now, for that first piece, the leftmost piece, which goes into this top box here, I'm going to do, it's a line, right? It's a linear equation. So I could try to figure out where it crosses the y-axis and try to use y equals mx plus b. But since I can just easily grab any other point and use the point slope form, I'm going to do that. So the point slope formula, let's review what that is. The point slope formula is this point slope formula, okay? So just like the slope intercept formula is really, or slope intercept form is really convenient if you have a slope and a y-intercept, the point slope is great with any point that's not a y-intercept. Now you could still use it if you had a y-intercept, but it would be kind of like extra work for no reason because the slope intercept would have been the easier choice if your ordered pair was a y-intercept point. Okay, so we're going to use this. And when we're doing it, we're going to just choose any point that is on the cross section of two grid lines so we can just make sure of what our values are. So this will be -5 for x and 3 for y. Okay, so that can be my x1 and my y1 for the formula. And then to get my slope, I'm going to choose another point, and I could use the slope formula, but that would be extra work actually, because being that we have the graph, we can just visually count rise over run to get our slope. Okay, so I'm going to start with, for that first point, first part, I'm going to do y minus 3 equals m times x minus a -5, so the double negative will become a positive. And then I'm going to replace the m with my rise over run, going from one point that intersects two grid lines and another point that intersects two grid lines. So I've already chosen my 2 points. So starting from this point, I can go, sorry, not that point. This point right here at -5, 3, I'm going to count down and over to this point at on the x-axis at -3. So I'm going to go from the first point down 1, 2, 3. Okay, so that's a rise. Let me replace it like this. Y equals, sorry, messed that up. Try that again. Y minus 3 equals my rise over run times x plus 5. Okay. Now the rise I just figured out is -3 because I went down. And then from there I would go over 1, 2, which is in the positive direction, so that's -3/2. So that'll be my first piece, but I need to write it so that y is all alone, because on what I have over on this side is my curly bracket pointing to f of x. Now f of x is just kind of another way of saying y. So this is kind of like saying y equals each of these pieces depending on where your x is falling or where your x is located. So I need to make this a y equals form so that I can write it as a function. So, but we do have some simplifying to do. So you could distribute the -3/2 times x, and then the -3/2 times 5, and then you have y minus 3, which if I add 3, this is the same thing as well, I guess I should extend. I'm getting a little sloppy here, but I'm starting to feel a little fatigued because I already did this question before in another video, and it was the exact same values I'm just recognizing. So I started to get a little sloppy there, thinking, oh my gosh, am I doing these exact same numbers again? And that should be a negative, since it's a negative times a positive. Okay, and then I'm going to add 3 to both sides so that I get -3/2 x minus 15/2 plus 3. So adding 3 to both sides would cancel it out from the left side. And instead of doing 3, let's write it as 6/2. And then -15 and +6 leaves -9. Okay, so that'll be the first piece. So I'm only going to write this side of it in that first top box. All right, now we're going to do the next piece. So we already have -3/2 x minus minus 9 halves whenever x is in between negative 6 and negative 3. Now we're looking at the next piece, which remember was for x that was going to start greater than negative 3 and up to and including 1. So this piece here, which is a horizontal line. We sometimes call these constant functions because the y value is constantly the same value. So you can just write this as y equals negative 1 because no matter which point you choose or which x value you choose in this interval, your y value is going to be negative 1 every time. Okay, so that's all we have to write for that one. Now for that third piece, and I don't remember which color I used for what, but we'll use burgundy here. Or is that fuchsia? Okay, let's see. We're going to go from 1, greater than 1. And how far does this picture go? Over to x equals 6. And that piece, again, I can use my point slope form on any point that I want. And I don't know, let's choose this one maybe, because it's got positive integers. It just makes life a little easier. So I'm going to do x equals 3 and y equals 2 for my x1 and y1. And once again, I'm going to be doing the point slope formula. So y minus y1 equals m times x minus x1. And then the slope, which is rise over run, all I have to do is count from any one point on the intersection of grid lines to another point that sits on a cross section. So now counting from this point, I'm going to go up 2. So that's positive 2 for the rise, and to the right 1, so that's positive 1 for the run. So now we have a slope of 2. So now I have y minus 2 equals 2 times x minus 3 quantity. Then I'm going to add 2 to both sides. Well, actually, I guess I should have distributed first. I don't know how I skipped that. And so now I have 2x minus 6. And then I can go ahead and add the 2 to both sides. And why do I start getting all sideways down towards the bottom? That's a different color. We'll do that one. So y equals 2x negative 6 plus 2. That looks a little weird. It's supposed to be a plus 2 is 2x minus 4. So that's the third piece. Now, if you wanted to test it out, you could. Let's erase some of this. And I'm just going to do some test points just to prove that this worked out the way it was intended. Okay, so let's pick an x value between negative 6 and negative 3. So what could we pick? We could pick, I don't know, negative 5 or maybe negative 4. So let's let x equal negative 4. What is the ordered pair going to be? So what is my y value going to be? Okay, so I'm going to take f of x and I'm going to plug in negative 4. Now because I'm plugging in a negative 4, I'm using this piece here. So negative 3 halves times x minus 9 halves. My x is negative 4. And then, so negative 3 halves times negative 4 over 1, the 2 can divide into 4 twice. And then I have a negative 3 times a negative 2 to give me a positive 6 from all of that. Okay. Then minus 9 halves. And I can rewrite 6 as 12 halves and get 3 halves when I combine those. So my ordered pair then, let's write it as a decimal, 3 halves is 1.5. Now let's see if it lands on that blue piece in the graph, that first leftmost piece. So the point negative 4 for x and 1.5 does land on that first piece. Okay. If we did it for an x value again, but in the next interval, so let's see, let's play around with it a little more. This time, let's pick something in this region. So from negative 3 to 1, let's pick 0. Okay, so now we're going to let x equal 0. So we're looking for the ordered pair when x is equal to 0. So f of 0, we would pick this because of the piece of the interval where x lies, and we would just get this. That's literally all we would have to do. Now let's test it out. If I go to 0, negative 1, I'm going to write that a little nicer. Uh, 0, negative 1 lies right on that constant piece, that horizontal piece. And then if I want to pick one from another interval, let's say I pick, let's pick something from 1 to 6. So maybe I'll pick 2. So if we let x equal 2, then what's our ordered pair going to be? F of 2, we would use this piece. So we would have 2 times 2 minus 4, which is 4 minus 4, which is 0. So at 2, 0, voila, there you have it, right on that piece.